Hello student, I am Arnav Das. Today we discuss about various kind of code for a digital communication. Proper encoding of information any digital communication or storage system will be lead to substantial increase in the noise immunity of the system without affecting the rate of information transmission and storage. This is the functional block diagram of a communication channel where a source will be present which generate the information and the output or destination side therein receiver is present. Let this is the sink. At the source side, their source encoder is present which generate the k-bit message signal and channel encoder convert into the form of n-bit code word. According to the type of the modulation, that particular n-bit code word is passed through the channel. It is then come at the receiver side with the first step of demodulator, then channel decoder, then source decoder. After that, it is coming at the sync position. So if we just recheck, then here at the information, there are an analog signal basically present. It is converted into the digital form by using the source encoder, and that one is the message signal as a k-bit form, and that particular k-bit message signal is converted into the n-bit as a code word form. And what type of modulation you are choosing for the communication purpose, that particular modulation is done by using the n-bit code word signal. Okay, and then at the receiver side, this total portion is the receiver side. Here demodulation first is occur on there. That means again you have to convert the demodulated signal as a form of n-bit code word before the channel decoder. The output of the channel decoder will be as a k bit as a message signal form, and source decoder it is convert into the requirement of the receiver side system. If it is a telephone or this is mobile, at the receiver side here should be required a voice signal for communication purpose as a verbal form. So here the basic fundamental or functional block diagram of a communication system. So proper encoding of the information is most important one. If this encoding process is not properly done, that time the message which is come at the receiver side not as a proper form. And here should be remember also their code word, that is the n, and the message bit k. Here n should be greater than the value of k. That means here extra n minus of k bit used for identifying at the receiver side is there an error is occur or not. And for this reason, this n minus of k extra bit which is added at the channel encoder position to represent the n bit code word, this will be defined as a redundant bit. Here ratio between k by of n, the ratio between message signal and code word, it is defined the r, and which is defined the code rate of the given channel or encoder. So these are the most important and basic view for the functional block diagram of a communication system, and obviously this is for the digital communication one. Now for the type, if we consider as a error control code, that time they are broadly as a two form. One is the block code and another one is the convolution code. If the memory element is present, that time that particular type of code will be that is a convolution code. That is that the previous data information also present at the present code word. For the block code, they depend only on the present input bit. Again, I just repeat that for the block code, it is depend only the present input. For the convolution code, there presents the memory element. The another kind of way it can be classified for the codes, it may be detect the error or it may detect and also correct the error. That means if and code can only detect is there any error is occur or not, that is it can raise their hand, yes there an error is present, yes there no error is present. So this kind of information if it is convey at the receiver side, that time this kind of code word will be defined as a detect code. That is, they can only detect is there any error is present or not. For the correct code, it is obviously detect the code and also able to identify where the error is occur. So this is the type for the error control code also as a form of it is ability to detect or correct. For the linear block code, obviously name is suggests that this is a one type of block code. That means there no information is stored for the previous one data. So it is depend only on the present data value. So for the linear code, a block code are the type code in which k tuple information is accepted at the time and the n tuple code word is formed. Previously, I told that n is greater than the value of k. Tuple means there how many formation can be created on there. As I say, k is the 3. That time for the 3 bits of data, their number of arrangement will be 2 to the power of 3. If the binary system you are treating, that time this is 2 to the power of 3. So for the 3 tuple, their number of formation will be 2 to the power of 3. That is 8 types of formation can be created on there. So by tuple, it is defined that there how many formation can be created on there. So here n is the total one as a code word. This one is defined the code word. If you consider this is the code word and which is equal to n, so n is equal to as a k bit message with the extra checking bit or redundancy bit, that is the n minus of k. So summation will become as a value of n. So this one is represent as a k bit information and n minus of k bit checking bit. For the generation matrix which is defined by the G as a underline double underline which is as a n comma of k, where n is defined the code word length and k is defined as a message length. This can be a symmetric form, or this is also defined as a sorry not symmetric, this is a systematic form, because by showing the ultimate code word you can differ which portion is the information and which portion is the redundancy bit on there. So this type of formation will be defined as a systematic form where you can easily able to differ which portion is the as a message and which one is the checking bit you should be used on there. For such representation, generator matrix G has to be of the form of G equal to Ik as a P. Ik means here message signal is defined as a Ik and P is defined as a redundancy bit as a matrix form. Okay. So for this kind of formation, their message bit is initially write down. For this one case, their message bit is initially write down, And if you write down in this form, that is G is equal to P colon of ik, that time ik or message signal will become after the redundancy bit or redundancy matrix. So if you write down the matrix form, that time how much row and how much column you should use, this will be dependent on what formation of n and what is the value of k also. If you know that one, that time ik will be a k cross k matrix or identity matrix, and P will be k cross of n minus of k parity matrix, or this is also redundancy matrix. So G is equal to as a form of G1, G2, Gk if there k is the message signal, and G1 can be considered as a G10 up to Gn minus of 1, because their generator matrix total generated code word length will be n on there. So their n tuple vector will be formed on there. So for the G1, their suffix 0, 1, 2, 3 is indicate for what particular message position for the bit 1, or it is defined at the bit particular position what will be the code word message. Okay, now this one is write down as a form of the matrix as a product term, that is the V is equal to of UG, where V is the matrix term and U also define the message signal, G is defined the as a generator matrix. If you multiply these two as a dot product from that time, V or code word can be generated for an uh, for various kind of book. It can be written as a C as a matrix form. C is equal to D of G, where D is defined the data vector, or this is the message, and G is defined, this is G is defined as a generator matrix one on there. So we just look an example for our analysis as a more interesting and obviously for better understand also. Let we consider U, that is the message signal is given to as a 1011. This is the message signal and generator matrix is given to as such. So what will be the code word for this message? You just multiply this to 1 as a dot product. So what happened? This is 1011. This row will be multiplied with the addition. That time the value will become as a 0. For this case, the value will be as a form of 1. So I think most difficulty will become on this addition, the initially addition and individually value as a plus 1. That is, if you consider for the first case, it will be, that is the 1011, and with the first as a column 1110, that time this will be 1.1 plus 0 um, 0 dot of 1 plus of 1 dot of 1 plus of, this is the mod operation, plus means 1 dot of 0. So what will be 1 dot of 1 means 1 plus 0 dot of 1 means it will be 0 plus of 1 dot of 1 means 1 plus of 1 dot of 0 means it is 0. So if you mod 2 operation you apply, then 1 plus 0 means 1, 1 plus again 0 1 means this is 0. So ultimate answer will become as is 2. Again I just repeat that we are doing here mod 2 operation. Okay, so for this reason this is so much uh, time consuming process to get that particular code word. So what will be the easiest way? You just check on there the where the 0 is present for the message bit. Here that this is the 0 is present in this position, so on that particular row for the generator matrix is just obsolete. Okay, and then you just add this particular column as a mod 2 operation form. So now the number is come present as a 1 plus of 1 plus of 0. First column, it will be 1 plus 1 plus 0. So this is 1 plus of 1 means it will be 0. So for this reason, this is come as a 0. Okay, this is come as a 0. Now, if you consider for the as you say this one position, this one position, this one position. So what happened? How can you calculate this one is coming as 1 or not? You just check that here which one you have to should be absolute, this one position. So this 0 you should be absolute. So it will be 1 plus 0 plus of 0. So result will be 1. So if you consider this one last, this is I think easy for the understand also. Let this one, that is the 1 0 1 1 for this column. So which one element you have to absolute? This the 0 will be absolute on there because here the message signal 0 is present. So I already told that where the 0 is present on that particular row for the generator matrix you should be eliminate. So this will be as a 1 plus 1 plus 1. So if this is 1 plus 1 plus of 1, that means 1 plus of 1 means it is 0, 0 plus of 1 means it is 1. So look that here the value 1 is coming for the near about the image bit position. So by this way you can got the individual message signal what will be the code word. And if you look carefully, the message is 1011 and here this is 1011. So this is the easily can be identified which one is used for the redundancy bit or parity bit. And if you look on their for the generator matrix, there the formation is given as a this is message and this is the I of k, this is the I of k and this is the p is given on here. Look at why this is I of k identity matrix. Look at this portion is the identity matrix on there 1 0 0 0 0 1. So here message parity bit is given to you as this one. Okay. So if generator matrix is not as such form, that is IKP or P of IK, then you should be convert or arrange on that particular one, and which is already I told the previous one, that is you should be arrange G as a form of IKP or as a form of G is equal to P of IK to get this is systematic form. Now for the another one example where G is given this one. So initially you have to check that is it is as a IKP or P of IK is present or not. Look that this is not as such. So for the G initially you have to rearrange as a form of P of IK or it is formed as a IK of P. Anyone you can be choose on there. Okay, not necessary that you should be follow this one. This one can be choose on there. Now by step it is written that to get the ultimate one value. Now the arrangement is coming as such by which the generator matrix is look like this one. Look that here this portion is indicate the IK. This portion look that this portion is indicate the IK. This is this portion. This is 1 0 0. This is identity matrix 0 1 0 0 0 0 1 0 triple 0 1. So this is the identity matrix. Now they are individual for the massive signal because the question is given that all possible code vector for the 7 4. So here n is given as a 7 and 4 is defined for the k. So massive signal is the 4. For the 4 bit their combination will be 2 to the power of 4 for the binary case. So there as if from this one this is the u, then for the previous example one particular value is given on there, that is the 1011. Here for the 4 bit each and every combination is given to you, and now you can know also the generator matrix. So by the same process, that is row will be multiplied with the individual column to get the first element. In such a way for the each and every cases if you do on there, that time you can got the value for the code one vector. As you say, for an example, if you consider for the last one as you say. So this is 4-1 on there as a message bit. So what will be the code one on that case? This will be as a 7-1 on there. How can you got this one? The process is that this row will be individually multiplied with the column 1. So here no one element you have to absolute. So 1 0 0 0 means this is value will be 1. For the second case 0 1 0 0 means here also 1. In such way you can got the value on there. So I think each and everyone can able to understand linear block code, and next day we should become with the another kind of code. And today we just stop in here for our topic, and if there are any queries should be communicated with me. Till have a good day, and now I have to say thank you.